Now let's proceed to the next technique, or the special integration technique, which involves trigonometric substitution. Now I know you've come across this kind of integrand wherein meron tayong squared, a constant, and then minus a certain constant. Diba this usually occurs when you have this inverse tangent, inverse sine. So yun, yung mga ganon, usually na-encounter niya siya, but before I introduced to you yung fitting integrand. That's why you can solve for it without doing trigonometric substitution. Now there is a case wherein we can use trigonometric substitution instead of you thinking of how we could just solve it using fitting integrands. So in short, ang pinakamadaling way is that if you have this square root of a squared minus u squared, you will let u. So basically, itong trigonometric substitution is another kind of u substitution. In a way na instead of using something like algebraic expression, we use trigonometric substitution. So yung trigonometric expressions natin would be something like u is equal to a sine theta when you have this a squared minus u squared. So, ang gagawin mo lang is that you let u, kung ano yung variable dito, say x, so that is let x is equal to, and then yung a would be the constant. So, yung square root ng constant. So, for example, let's just use, for example, yung ating square root, let's say ganito, square root of 9 minus x squared. So, yung u mo would be u is equal to 3 sine theta. So, ganito yung mangyayari dyan. Pattern lang natin, you take the square root of yung constant, and then yung u mo would be 3 sine theta. So parang gano'n lang naman siya. Actually, hindi siya u, no? This should be let x. Okay. So let x dapat yan. Kasi kung ano yung variable mo, yun din yung ilalet mo. Okay, so gano'n lang siya. And then for our plus, pag plus yung nasa pagitan ng variable at constant squared, then you would be using tangent theta. But if it's minus, then you use secant theta. Now, let's be particular with this, no? Kapag nauna yung constant and then yung variable, so you use sine. Kapag nauna yung variable sa constant, then you use secant theta. Okay, so correspondingly, sabi dito, if the above expression is reduced to its form, then you will be seeing ganito yon mangyayari. Basta mapapansin yun pag nag-solve tayo, no? Magiging ganito yung form, and then you will be having this a minus a squared sine theta. So yung kanyang equivalent would be a cosine theta, kasi alam naman natin na this is 1 minus sine squared theta. So that is cosine squared, and then you take the square root of that, so that's a cosine theta. And that's the same thing that works for the other two expressions that you can see. And ito, basahin ko lang to. It is important to remember that when definite integrals are evaluated, some functions behave like absolute value functions, especially those even trigonometric functions. In addition, substitution may be used interchangeably. So, in short, kapag gusto nyong gumamit ng mga gantong form, you could use absolute value sign para hindi tayo maligaw, no? Ayun. Ganun lang siya, no? And then, let's try solving for this using trigonometric substitution. So, I think I'll be doing, ano bang gusto nyo dito? I think I'll be doing, sige, para maiba naman, I'll be doing the odd numbers. Okay? Para mas marami naman yung sa akin. Sabihin nyo naman unfair ako. Sa akin yung odd numbers, and then at your home, you solve for the even numbers, diba? Para at least may practice kayo. Parang pula ng ano ko. Puntok. Anyway, so, ayun. And let's start solving for the odd numbers. Alright, so let's have number 1. Sabi sa atin again, pag ganito yung form, we use, ano ba yan? Meron tayong constant, and then meron tayong variable. So, addition, yung kanilang middle operation. So, pag ganito, diba, we use tangent function. So, kung makapansin nyo dun sa inyong handout, diba, that is square root of something like that, no? Pero it doesn't necessarily mean na kapag hindi na siya naka-square root is hindi mo na siya pwedeng gamitin. So, basta ganito yung form, kahit pa siya is nasa square root or wala, you can actually use it naman. So, from this, di ba itong form na to, pag sinolve natin siya using at our common method, we can actually do long division for this case. And then, dun sa long division na yun, we will be applying yung ating probably hitting integrand kung ganon. Pero for this case, let's do trigonometric substitution immediately, no? Huwag tayong mag-long division. Try natin kung makukuha natin yung sagot. So from this, I will let x is equal to, di ba yun ay 1 kasi square root of 1. So that is square root of 1, then tangent theta. Okay? With this, the derivative would be equal to secant squared theta d theta. And then, I know naman na kapag meron tayong x to the fourth, this is actually equal to tangent to the fourth theta. Okay, so upon substitution with this expression, we could say that this is the integral of tangent to the fourth theta, okay, divided by this is 1 plus tangent squared theta, and then divided by, multiplied by secant squared theta d theta. Okay, so ganyan yung magiging form natin, no? And then, remember, sabi natin sa identity natin na if we have an expression that is 1 plus, di ba sabi natin, pag 1 plus tangent squared theta, di ba alam natin na this is secant squared theta. Ito yung ating identity, di ba? So, from this, we could just simply cancel this out kasi they are of equal terms, di ba? They have the same identity. So, from that, we'll be left out with this expression, which is a very basic in this case, that is the integral of tangent to the fourth theta d theta. Okay? And then, ano ba yung sabi natin sa handout kapag meron tayong ganyan na form? Kasi that is tangent to the fourth theta, and basically, sabi dito, kung babalikan natin yung ating learnings sa previous natin, I'll be checking that out kung nandun nga ba talaga siya. So, I'll be checking it out kung nalagay ko nga siya doon. Kasi kung hindi naman, edi, wala pala dito, di ba? So, sabi dito, nasan ba yan? I think I did, yan. Itong portion of the letter F. A product of the form, sorry, hindi pa siya product, no? Ayan. Ito, yung letter D natin. A power in the form tangent NU or cotangent NU, where n is a positive integer, can be integrated by using the trigonometric identities. So, in short, gagamit tayo ng trigonometric identity dito. Kasi, sabi dito, ganun mo siya i-integrate. So, therefore, we'll be substituting this in terms of secant squared theta and then minus 1. So, gagamit lang ulit natin identity nito, diba? So, we raise this to, diba, this is tangent squared theta. So, alam naman natin na we have to square this para maging equivalent silang dalawa. Okay, so, ano ba yung essence dyan? So, what we will have to do here is to expand that. So, we have the integral of secant to the fourth theta. Okay? And then, that is minus 2 secant squared theta, and then plus 1, and then d theta. Okay? So, can this be integrated in a way na, can this be integrated sa ating previous discussions? So, alam naman natin na for this case, the secant to the fourth is not readily integrable kasi hindi naman kasi sa secant squared theta f. Pero, what if we try to rewrite this in the form na that is secant squared theta and then that is multiplied by 1 plus tangent squared theta. Will this be integrable? So, the answer is yes, kasi ganito yung gagawin natin dyan. Multiply talaga natin yan, no? So, I think I'll be having something like this. Okay, so ito na yung final form natin ng ating integrand. So, ba't ko ginawang ganun? Una kasi, itong secant squared theta na to, plus 1, yan ay readily integrable na. Pwede natin siyang ma-integrate. But this secant to the fourth theta, again, hindi siya readily integrable kasi when we try to integrate yung ating, or differentiate yung ating tangent, diba secant squared lang lumalabas? And hindi natin napapalabas yung secant squared theta in a sense na Galing siya sa isang certain function. So, what we have to do here is to apply yung ating identity in a way na yung 1 plus tangent squared theta is secant squared and then this is secant squared. Kasi, pag in-expand natin yan, you'll notice na this becomes secant squared theta, okay? And then plus secant squared theta, tangent squared theta, then minus 2 secant squared theta plus 1, okay? And then we can lump this secant squared into 1. That's why we'll be left out with this expression. Okay. And this is very easy to integrate, itong expression na to, no? Kasi una sa lahat is unahin natin. O sige, mag-integrate na tayo, unahin natin itong middle term. So, di ba, secant squared theta is the exact antiderivative of tangent. I mean, the derivative of tangent theta. So, therefore, the antiderivative would be tangent theta. I mean, negative tangent theta. Okay, and then this plus 1 would be plus theta. But how about this one? Now, remember, if you let u this tangent theta, the derivative is the secant squared theta. So, therefore, para lang siyang u squared du. And therefore, the derivative of this, I mean, the antiderivative would be 1/3, and then that is tangent cubed theta. Okay? So, that's it for this problem. Okay, so, yun na yun. Plus C. So, yan, ganyan siya sinosolve. Kasi, di ba, it is 1/3. So, mangyayari dyan, maging tangent squared theta and then secant squared theta pag din-differentiate natin. So, this is our answer. But then again, this all came from the fact na this is in terms of, I mean, a u substitution, I mean, an x substitution in terms of theta. So, we have to bring this all back to the same or the original variable that is x. So, gawin natin yun, no? So, this becomes 1/3. And then, yung tangent cube is actually x cubed, diba? So, that is x cubed. Okay? And then, minus, yung tangent is x. Okay? And then, plus theta. Now, how do you obtain this value of theta, no? So, you can check this theta here. And then, alam naman natin, diba, na if you want to take this theta, you can just take the inverse tangent of both sides. So, you'll be able to get yung theta lang. So, that is the inverse tangent of x. So, therefore, this is the inverse tangent of x. And then, plus c. So, therefore, our final answer is this expression. 1/3 x cubed minus x plus inverse tangent of x plus c. And let's check if we've obtained the correct answer. Okay, so I think we have the same answer for this problem number 1. Now, what if you try to do long division and then you try to solve for it? And then you'll be able to get the same result for sure. Kasi imagine, kung i-long divide natin to, we will be expecting na we'll be obtaining two whole numbers of x variable. That is, yung isang squared at saka isang x, which is typically this one. These two, rather. So, yun na yung dalawa na yun na nasa quotient. And then, yung ating magiging final answer dito would be divided by 1 plus x squared. Which in turn becomes the antiderivative of our tangent. I mean, the antiderivative is the inverse tangent of x. So, basically, same lang yung makukuha nyo dyan procedure. But if you don't believe me, you can also try to perform long division and then just divide it. Now, bakit di siya pwedeng apply ng partial fraction decomposition? So, una, this can't be applied, that method can be applied because hindi siya proper kasi kung mapapansin nyo, di ba, hindi siya proper. Pangalawa, though this expression is irreducible, there is only one factor at the denominator, which is 1 plus x squared lang. Hindi natin siya kayang i-factor out into simpler terms. So, kung magagawa ka ng partial fraction, the only way that you'll be, I mean, the expression that you'll be getting, the partial fraction, would just be the same expression as this one. So, parang, kung ipa-partial fraction mo siya, same lang din yung integral na makukuha mo. So, walang changes. Kaya, walang sense, diba? So, in this case, we will be using, or the best method to be used is trigonometric substitution. Then again, kung hindi kayo sanay pa kasi nakakalito pa, so you can just use your fitting integrands. That's still okay. Okay, so let's proceed to the next odd number, that is, ayun, kita nyo naman dito, no? Number 3. Okay, so for this case naman, let's solve this by yung ating ordinary methods muna, no? I mean, Yun muna ang basic integration procedure yung ating i-apply dito. Bakit? Kasi, una sa lahat, hindi naman to kagaya ng ating trigonometric substitution na meron na agad siya naka-square na variable and then constant. Kasi makikita natin meron tayong trigonometric identity na dito eh. I mean, trigonometric function na siya. So, I'll be redefining this by multiplying this with the reciprocal of sine squared theta. So, that is cosecant squared theta. So, ito yung ginamit ko. Kasi I'll try to do use substitution later. Kasi kung cosine gagamitin ko dito, wala ding mangyayari sa atin kasi hindi natin siya mapapalabas dun sa ating antiderivative or dun sa derivative ng mismong sine natin kasi may matitira pang cosine sa ilalim. Pero if this is the case, I can use another function wherein the derivative would result to cosecant squared theta. So this becomes cosecant squared theta d theta, and then we divide this by 3 and then plus cosecant squared theta, diba? And then sabi ko kasi, gagamit ako ng isang function na magre-result sa cosecant squared theta. That is cotangent, diba? Alam natin na yung cotangent, pag din-differentiate natin, magiging cosecant siya. So, gagawin ko tong cotangent, itong cosecant squared theta, by using the identity na 1 plus cosecant 1 plus cotangent theta. So that is cosecant squared theta d theta divided by 3 plus 1 plus cotangent squared theta. Okay, so yun yung identity ng cosecant natin, diba? And then from this, we could just write cosecant squared theta d theta divided by 4 plus cotangent squared theta. Okay, and now let's have u substitution. Let u is equal to cotangent theta, du is equal to negative cosecant squared theta d theta. And we're writing this back to the original expression. We have the integral of, I think that's negative du over 4 plus u squared. Now from this expression, we can already integrate that by fitting integrand. So we know naman that this is inverse tangent. So that is negative 1 over a, so that is 1/2, and then the inverse tangent of u over a, so that is u over 2 plus c. Okay, so that's it for this expression. And then you can rewrite this in terms of negative 1/2 inverse tangent, and what is the equivalent of u? That is cotangent theta divided by 2 plus c. So this could be your final answer for this case. Now, what if you did u substitution in this case? Kasi pwede yun, diba, dito? So let's have another solution. So if we let u equal to 2 tangent theta, kasi pwede yun dito, diba? Du would be equal to 2 secant squared theta d theta. Correct? And then if you try to substitute that, we have the integral of 2 secant squared theta d theta, may negative sa unahan, and then all over 4 plus, so u squared would be 4 tangent squared theta, diba? And then kung ifa-factor out natin yung 4, we'll be left out with 1 plus tangent squared theta, which makes sense that this expression at the denominator becomes 4 secant squared theta, okay, by the identity. We can cancel this out, and then we'll be left out with the negative 1/2 d theta, which gives us the antiderivative that is equal to negative 1/2 theta. Okay, so plus c. So ano ba tong theta na to? So iba siya dun sa ating expression kasi yung theta. Para maging u, we can take this original let u natin and then take the inverse of tangent, and then you'll be able to get theta. So theta is equal to the inverse tangent of u over 2. Kasi pwede ko namang i-divide to both sides by 2 and then just take the inverse tangent of that. And then we can rewrite this in terms of negative 1/2 inverse tangent of u over 2. Kasi this one is obtained from this expression u over 2. And then yung u natin, diba, from this it is cotangent, so that is negative 1/2 inverse tangent of cotangent theta over 2 plus c. So this is the same as this expression, so you can have this as your final answer as well. Now dun sa inyong handout, I think the answer is something like this. The answer is kind of different in form, but they are actually the same. That is 1/2, and then the inverse tangent of that is 2 tangent theta plus c. So remember, if you try to take the negative of this expression and then just do yung twice ng tangent theta, that should result to this expression as well. So you might as well want to try that. So ito kasi sometimes yung redefining natin, kapag dumaan siya sa ibang form ng redefining, makukuha mo yung nasa result ng handout. Pero since I use cosecant squared theta, so mostly this will result to this expression without any applying yung ating identity dun sa final answer. Kasi pwede naman na mag-stop na tayo dito. But then again, if you try to apply yung ating identity, so from this, let's just use the identity na something like this, no? So if you have inverse tan, let's use another color. If we're talking about angles with the same reference, no, from the positive x-axis, then yung inverse tangent of x would be equal to the negative inverse tangent of 1 over x. So this would be the same thing naman. So if we'll try to apply that concept in this case, so we'll be having positive 1/2 inverse tangent of negative, so negative of the reciprocal of this expression, that is 2 over cotangent theta plus c. And this reciprocal of cotangent theta yields to tangent theta. Okay, so with this, we've arrived at the same result as this, the one in your handout. So hopefully ay nagets nyo yung ganong concept, no? Now to visualize that, let's use yung ating graphs, no? So for example, meron tayo unit circle dito, and then we have, let's say ito yung theta mo na nakuha from the positive x-axis using this expression tangent inverse of x. So yun yung value niya, and then what if kinuha natin tong value na negative inverse tangent of 1 over x. So from the positive x-axis, from this angle, di ba, lagi kasi siyang complement. So if you try to add 90 degrees from this, so mangyayari dyan, makapunta siya sa somewhere here para maging complement. So this is your theta. So basically, measure nitong angle na to would be, of course, yung eto, technically, from positive x-axis to that angle. That's why iba yung measurement na makukuha mo. But then again, if you try to take the magnitude in just restricted lang tayo dun sa reference angle natin na as axis, either x or y, then we will have the same result for this. Kaya medyo iba yung ating makukuha sagot when we try to calculate its value pag binigyan natin siya ng values ng x sa calculator. So pag ganun, kung mapansin nyo, actually mag-iiba talaga siya. But then again, ito yung property niya na pwede natin i-apply. Pero if you're not sure about this, you can just stick with this answer. Okay? Para hindi tayo medyo maguluhan, no? Kasi ito, unlike other kasi na angles sa coterminal, this one is a little complicated kasi we're dealing with angles referenced from the x-axis, but then again, kung i-calculate natin to, this should have any angles na nagre-reference either y or x-axis. So yun lang. I just wanted to show you na this is still equivalent to this expression as long as yung ating reference, we're talking about dun sa y and x when we try to solve for the angle. So yun, and then I want you to stick with this first answer in this case. So hindi ko sinasabi malito, it's just that mas nakakalito siya kapag in-apply natin ng gantong formula, which is tama naman yan, and this is actually a result of another method na ginawa natin. Ay, nabura. Halimbawa, nag-redefine tayo from this expression and then iba yung ginamit nating method. So mostly or most probably this will be the result, and that is also a correct answer. But then again, since we use cosecant squared theta, ito yung nakuha natin, then we just stick with this. So hopefully ganun din yung maging nyo, mga solution nyo if ever. So kung may iba kayong solution, and then just try to prove it if it's the same as the one in your handout, and then from that, magaguess nyo yung ibang properties ng ating mga trigonometric identities. Okay, so let's proceed to number 5. Okay, so ano ba yung gagawin natin dito? Kasi ito, meron siyang b squared plus x squared, which conforms with trigonometric identity using tangent. Ito naman for something like sine theta, diba? Ano yung gagamitin natin for this? So before we do that, let's take a look at the integrand first. Alam naman natin na may x pa dito sa unahan. And then, if you try to let u yung ating x squared, di ba this is actually the derivative of your x squared, that is 2x, something like that. So, let's perform muna yung u substitution from this. So, that is let u is equal to x squared. So, du would be 2x dx, which in turn, we can represent this in terms of 1/2. Okay? So, 1/2 the square root of b squared minus u over b squared plus u, and then this is du. Okay, so with this medyo mas ano na siya, mas simplified version na siya ng ating integrand, 'di ba? Mas ano siya, mas parang mas okay naman tingnan, 'di ba? And then what I'll do next is I'll try to redefine this expression, no? So what 1/2 the integral of this is square root of, actually you can just separate na yung ating integral, radical sign, pwede naman yun para mas makita nyo na maigi. Then I'll try to redefine this using so actually pwede nyo i-redefine siya either numerator or denominator, but then for this case I think I'll try to use yung ating conjugate gagamitin ko dito. So that is square root of b squared minus u, and then square root of b squared minus u. Bali, conjugate nung ating denominator. So that is 1/2, and then the integral of, this one is b squared minus u na lang kasi makakancel out yung ating sign dito, radical sign. And then this becomes b squared minus u, b to the fourth. That is b to the fourth minus u squared, and then meron pa tayong radical sign for this. Okay? So, I hope malinaw yung redefining na process na yun. And then from this, I'll try to perform trigonometric substitution by having u, diba? U kasi dito. So, u is equal to, diba, square root of b to the fourth, b squared, and then, since this is, constant and then variable, so I'll be using sine. So, that is sine theta. Okay? And then du would be equal to b squared cosine theta d theta. So from this, we have 1/2 the integral of b squared minus b squared sine theta divided by square root of b to the fourth, and then minus, so i-square natin yung u, so we have b to the fourth and then sine squared theta d, hindi siya d theta agad, no? Meron pa tayo dito, so that is b squared cosine theta d theta. Okay, so ito yung ating expression. We can simplify this further, so we have 1/2, and then we factor out b squared muna dito para hindi tayo magulo. So we have 1 minus sine theta, and then multiplied by this, so gawin natin itong b to the fourth na lang. So b to the fourth, and then meron ditong cosine theta d theta, and then divide this by, ito ngayon magiging b squared, b to the fourth quantity 1 minus sine squared theta, which is cosine squared theta. So with this, yung magiging sagot dito is b squared cosine theta d theta. Okay, so pwede natin itong cancelin. Okay, and then yung isa pang squared which is b squared. Therefore, we'll be left out with 1/2, and then the integral of b squared 1 minus sine theta d theta. And this can easily be integrated, diba? We can factor out b squared kasi this is constant, so we can just write it in front of our integral sign. Okay? And then, ito din, pwede natin siyang integrate. Pwede nga ba? So, pwede. So, we have, let's use another color na lang dito. So, with this, we have b squared over 2, and then the antiderivative of 1 d theta, so that's the theta, and then minus. So, this is minus cosine, so that is plus cosine theta plus c. So, yun na lang yung problema natin, yung theta. So, we have to bring that back to the original expression, which is u. So from this, yung theta natin, di ba, we could just obtain that from this expression that theta is equal to the inverse sine of u over b squared. Okay, so that is inverse sine of u over b squared plus cosine theta plus c. Then again, we still need to replace all of this u in terms of x. So we go back to this original expression and then we substitute. So we have b squared over 2 quantity sine inverse of u, that is x squared over b squared, okay? And then plus yung ating cosine theta. So, hanapin natin kung ano ba yung pwede natin makuha sa cosine theta. So, ngayon, gagamit ako ng triangle to let you see what happens. So, di ba, if I have a right triangle here and my angle is theta, di ba? So, theta yan. So, di ba, pag nire-write ko to in terms of sine theta, I can say na that is u over b squared. So, therefore, kung meron tayong, kung ang ating hypotenuse is 1, so yung atin, di ba, sabi natin, sine theta is equal to opposite over hypotenuse. So, kung ito yung opposite ng angle theta na yon, that is u over b squared, correct? That is kasi, sine theta is equal to u over b squared all over 1. That is opposite over hypotenuse. So, what happens with this adjacent? So, therefore, you can determine the adjacent by taking yung square ng hypotenuse minus the square of your this other leg. So, that is u squared over b to the 4th. So, therefore, ang cosine mo is this value, square root of 1 minus u squared over b to the 4th all over 1. Okay, so that is plus square root of 1 minus u squared over b to the 4th all over 1. So, hindi ko na siya isusulat. And then, plus c. Okay, so, medyo crowded na tayo. I think I'll be removing this na lang. Kasi, ano naman tayo, galing lang naman to sa differentiation. Okay, so, I'll try to simplify this further. So, we have b squared over 2. And then we have the inverse sine of x squared over b squared. Now, hindi nyo to isa-simplify into x over b, ha? So, walang ganun. And then plus, now ito, we can have b to the 4th minus u squared all over square root of b to the 4th. So, that becomes 1 over b squared times square root of b to the 4th minus u squared. Okay? So, ito yung isang pwedeng form niya, and then plus c. Now, we can distribute this b squared, or pwede naman ding hindi. It's up to you, no? But then again, this is your not yet the final answer kasi meron pa tayong u squared dito. So, we have to still change this in terms of that expression. So, this becomes x to the 4th. Okay? So, yun. So, mostly, this is your final answer for this problem. Okay? So, ganun lang naman siya. Balik-balik lang tayo dun sa ating original form. Okay? So, in your handout, that is 1/2. Let's check. That is 1/2 b squared. Okay, so distributed dito sa handout, no? That is 1/2 b squared. Okay, so that's correct. Sine inverse of x squared over b squared and plus. Okay, so ito ata yung may actually meron kasi akong mali dito eh. Pero hindi ko alam kung na-correct ko na. Pero parang okay na siya. Okay na pala, na-correct ko na siya. Kasi plus 1/2. Kasi pag dinistribute natin tong b squared dito sa ating dito, diba, magka-cancel out yung b squared. So, matitira lang is 1/2. So, tama yung nasa na 1/2 and then b to the 4th minus x to the 4th plus c. Okay, so, that's correct. And, I think we're down with the last. So, number 7 na tayo. For trigonometric substitution. So, hopefully, ay nag-guess yung idea, no? Again, kapag meron kayong other variable, let's say, sine lang yung u nyo, diba? Dito, sine lang. Pero sa result nyo ng antiderivative, meron kayong either cosine or tangent or other trigonometric functions na wala sa inyong u substitution. You do right triangle, okay? Just let the hypotenuse equal to 1. And then, kung ano man yung nanditong equivalent ng inyong sine or cosine, just place it dun kung saan man corresponding leg niya. Either at the, let's say, dun sa hypotenuse, let's say dun sa adjacent or the opposite. Now, what if, halimbawa, nag-try kayo, u is equal to, let's say, ganito lang naman ha. Halimbawa, ganito yung nangyari. A and then tangent theta. So, ito yung given mo from this. So, gagawa ka ng triangle and then, how do you do something like this? No? So, alam na natin na pag tangent, diba? This is the ratio of your leg to your, your leg to your your opposite to your adjacent kasi that's sine theta and then cosine theta. So, assuming that this tangent theta will yield to u over a kasi this is obtained from this expression. No? Then the ratio, you could just use yung itong u mo is your opposite and then yung a mo dito is your adjacent. But just make sure na yung iyong hypotenuse is not 1 but the square root of a squared plus u squared, kasi that is how it works for Pythagorean theorem. Basta dalawa lang yung pwede mong bigyan na assumptions dyan, and then not really assumptions but yung pwede mo ma-obtain yung dalawa, and then the rest, yung last leg would be evaluated from those two legs na you have already the value or the expression. Okay, so I think let's move forward na sa last number. Okay, number 7. So, ang daya kasi para akin lagi yung complicated. Anyway, so at least, 'di ba? Doon kayo sa mga hindi gaano complicated. So, let's have it for letter number 7. Okay, ito lang yung ating expression, square root of a squared minus x squared all over x dx. But to tell you honestly, this is really not easy. Kahit mukha siyang simple lang, no? And what approach could be done in this case? So, gawin natin, since mukha na tong pwedeng gawa ng trigonometric substitution, edi diretso na tayo. A squared minus x squared, diba? Ano ba ito? Diba this is sine kasi we have a squared minus x squared. So, you can have let x is equal to a. Let's have another color para kita natin yung solution. So, we have let x is equal to a sine theta. Okay? Therefore, dx would be equal to a cosine theta d theta. And then from this, we can rewrite all the expression in terms of square root of a squared minus a squared sine squared theta. Okay? And then divided by a sine theta, and then times a cosine theta d theta. Okay? And then this becomes a squared times 1 minus sine squared theta. That is that becomes a times 1 minus sine squared theta, then a cosine squared theta, and then we have a cosine theta. Okay, so sana nasundan nyo yun pero kung hindi talaga is ila-write ko na dito. Diba magiging ganyan yan? And then magiging a squared cosine squared theta. So you just take the root of that and then you'll be able to get this. Okay, so ito na yung magiging final natin, final output. So we can just cancel out yung a dito para hindi na tayo maguluhan. So we'll be left out with a, and then ganito siya, a cosine squared theta over sine theta d theta. Okay, for the next one, how do we deal with this expression, no? So, hindi na tayo mag-use substitution dito kasi alam naman natin na if we do that, we need to express this in terms of cosine d theta yung numerator. But then again, meron pa tayong isang cosine kaya nga naging square top. So, hindi pa siya applicable for this case. So, what I'll be doing is that I'll apply yung ating identity for cosine, that is 1 minus sine squared theta, and then sine theta d theta. Okay? And from this, I can actually rewrite this in terms of aking pagdadissectin yung ating mga expressions sa numerator. So that is a, the integral of that is 1 over sine theta, so that is cosecant theta, diba? And then minus sine theta d theta. Okay? So, can this be integrated easily? So the answer is yes, kasi mas madali itong integrate. So we have a times, so the antiderivative of this cosecant theta is the ln of cosecant theta minus cotangent theta. Okay, you can always check that. So 1 over cosecant theta minus cotangent theta, and then derivative, so you'll be left with cosecant theta. Now you can use yung negative tapos cotangent and then minus cosecant theta, so pwede rin, or plus, I think actually negative and then plus, pwede yun. And then minus, so this is a plus cosine theta and then plus c. But then again, this is not yet the answer. We have to express that in terms of x. So going back to this, no, ito yung sinasabi kong medyo complicated kasi yung x natin is in terms of sine theta. So yung cosecant, wala tayong problema dito kasi if we have your sine theta that is equal to x over a, we could say na yung ating cosecant, which is the reciprocal of your sine theta, is simply a over x. So, okay na tayo dito sa cosecant. But how about our cotangent and then our cosine? So, what we have to do is to draw, again, yung ating triangle. And then ito yung theta mo, and then yung ating opposite is x over a. This is 1. And therefore, yung ating cosine would be something like 1 minus x squared over a squared. Okay? So from this, we'll be deriving the other identity. So that is a, and then that is ln of this a over x, and then cotangent. Again, cotangent is simply cosine over sine. So that is the adjacent over the hypotenuse. So that is square root of 1 minus x squared over a squared divided by the opposite, that is x over a. Okay? And then plus the cosine, that is simply square root of 1 minus x squared over a squared, and then plus c. Now, you might want to stop here. But then again, I'll try to, I think, simplify this further. So, saan ko ba pwedeng ilagay ito? Dito na lang. Okay. So, ito try kong simplify to, no? Simple lang naman yun. Ano lang naman. So, we have a, and then ln of a over x, and then minus. So, from this, diba, that becomes a over x as well. Pero ito, we'll be having a squared, something like square root of a squared minus x squared, and then divided by a squared, so that is divided by a. Okay, and then this will leave us to over x only. Okay, so hopefully ay nag-guess nyo kung ano nangyari dito, kasi this will be multiplied by a, but this will be divided by a. So kaya makakancel yung a, and then plus, that's why the same thing will happen here, diba? So that is square root of a squared minus x squared divided by a, and then plus c. So this could be your final answer. Now we can also, pwede natin to kasi ngayon i-write pa in terms of single expression. Kasi diba, this is a minus square root of a squared minus x squared over x. Diba pwede yan? And then, kasi isa lang naman yung denominator nila, and then plus square root of a squared minus x squared all over a, and then plus c. Now, this is in terms of a over b. Pwede mo rin siya actually pag-subtractin kasi, diba, that's the property of your ln. So, you can have ln of a, and then minus, ln of a minus square root of a squared minus x squared, and then minus ln of x. So, pwede yan. And then plus, pero ito, same pa rin sila. So, that's 1 over a, and then square root of a squared minus x squared, and then plus c. Okay. Now, you can actually distribute yung a, pwede pa yun, and then you can have a, and then ln of a minus square root of a squared minus x squared, and then minus a ln of x, and then plus square root of a squared minus x squared plus c. So, this could be your answer. Okay? Pwede rin naman na ito, pwede rin to. Okay? And then, of course, pwede rin ito. So, you can have multiple forms of the answers here. And then, check natin yung handout. I think the one in the handout is yung pinaka-last. Okay? So, yun yung a, ln of a minus square root of a squared minus x squared. Kaya ako sinabi itong complicated kasi ang complicated dito is yung simplifying as well as yung paggamit ng triangle. Pero yung ating paghahanap ng antiderivative is not really that complicated. So, yun. That's it for your special techniques using trigonometric substitution. So, I hope naintindihan nyo na siya, no? Now, yung number 7, kung isipin nyo, is yung fitting integrand possible or yung solution na basic procedure. So, I don't think it is applicable for this case. Kasi, had it been, baliktad, let's say, x over a squared minus x squared, this could have been easier sa basic integration procedure. But then again, since hindi siya baliktad, no, I don't think we have another way but to use trigonometric substitution in that case. Okay, so yun lang. But then again, kung may naisip pa yung other way, using fitting integrands or a basic integration procedure, walang problema. Sabi ko nga, you're free to do anything here, kahit anong method na dito. Kasi before, I restricted you in using any methods na special integration techniques. Kasi gusto ko makita nyo kung paano siya ginagawa in basic integration procedures lang. Kasi, ewan ko, I think it's essential for you to learn the basic muna bago itong mga special techniques. So, basta sa midterm, free na kayong gumamit ng kahit ano. Okay. So, I think that's all for your trigonometric substitution. I hope naintindihan nyo to. Ulitin natin, pag partial fraction decomposition, we have this rational expression, and then pag irreducible proper, we use that. Secondly, kapag meron tayong expression na in the form variable squared plus constant, we usually use trigonometric substitution as long as these three main functions ng trigo can be substituted to that certain integrand. And then I think we'll be moving forward na dun sa one of the most favorite kasi pinaka almost favorite ng lahat ng nag-aaral ng integ, this integration by parts. And mind you, integration by parts is one of the most special cases kasi this deals with the more complicated stuff in mathematics na usually mahirap talaga siyang integrate kapag hindi alam ang knowledge or walang knowledge about integration by parts. So let's go back to the manual, our module, and then let's have some quick discussion muna.